Let me now show you another example for how to apply the node voltage method to solve a circuit. This time let's put a current source and let me show you how to handle that. So here's a kind of simple example. Suppose we have a current source, a resistor, we'll put another resistor here, and then let's attach a current source over here and see how we handle this using the node voltage method. So I'm going to let this be a 24 volt source. We'll let R1 be 100 ohms. Let's let R2 be 25 ohms. And let's follow the steps for the node voltage method. The first step is we label all nodes. We only have one node in this circuit and it's up here, so I'm just going to label this V1. The next is we're going to designate a reference node. I'm going to make this bottom node here my reference node. I'll label it with ground so that it just reminds me that I'm going to consider the voltage here to be 0 volts. And then the next thing I'm going to do is I'm going to use KCL to write a current equation at node V1. To write current equation at node V1. Okay, great. So what do we have here? We have a 24 volt source that's generating a current that's going towards V1 like this. We have a current source over here. I didn't label this. It's 40 milliamps. So that means the direction of the current down this branch is going to be this way. And then we're going to have current that's going to take the path through this R2 resistor that's going to go down to ground and complete the loop here. So if we wanted to write my KCL equation at this node, then at V1 by KCL, I have that. If I label this as I1 and I label this as I2, I have the sum of the currents coming into the node is equal to the sum of the currents going out by KCL. So that means that I1 is equal to I2 plus this current here is 40 milliamps, so I'm just going to write that in amps, 0.04. Great, so then my next step is I'm going to use Ohm's law to replace the current in my equation with V and R. So I'm going to rewrite these currents in terms of voltage and resistance. So here's the substitution that we make. I1 we replace with the difference of nodes divided by the resistor between. So this is going to be 24 minus V1 divided by 100 ohms because we have a 100 ohm resistor between 24 and V1. I do 24 minus V1 instead of V1 minus 24 because this is the direction of my current. So I'm starting here and going towards V1. Great, so then my I2 is going to be V1 minus 0 divided by the resistor between, which is 25. V1 minus 0 over 25 ohms. And then my I3, I already know what this is because the current going down this branch is listed by the source as 0.04. So now I'm ready to make my substitution. My equation is now 24 minus V1 over 100 is equal to V1 over 25 plus 0.04. So now I'm just going to do a little bit of arithmetic to solve for V1. I'm going to multiply everything by 100 and that gives me 24 minus V1 is equal to 4V1 plus 4. So that means that 20 is equal to 5V1. In other words, V1 is equal to 4 volts. So now I know the voltage at this node right here. If I'm asked to, I could find the current through here just using Ohm's law and finding the power that's dissipated through this resistor. Same story with this resistor. So let me know if you have any questions for how to handle a current source using the node voltage method.